Okay guys, mechanics week 9 CA. Possible equation of motion of a particle moving in the positive direction at constant speed is... Okay, so this is the equation of a particle moving at a constant speed. X equals Vt plus x0. Okay, and they said in the positive direction, so V has to be positive. Okay, so this one, no, V is negative. This one, V is 1 and x0 would be -1. So it would be, yeah, x0 would be -1. So this one's correct. This one, x is negative, and this one, t squared and t squared. So, no. Okay. Okay, the acceleration of the particle between 0 seconds and 2 seconds. So here you just find the slope of the Vt graph. So from here to here. So the slope of the Vt graph. So V final 4 minus V initial 0 over 2 minus 0 is gonna equal 2. Also you can use V equals AT plus V0. V is gonna equal 4 equals A. T is 2, so times 2 plus V0 is 0. Also here you're gonna get A equals 2. You can use whichever one you like. So it's 2. The displacement of a Vt graph is the area under the graph, and it's a trapezoid. So the formula is base 1, so 10 plus base 2, which is 6 minus 2, so 4, over 2 times the times the height, so 4. So 10 plus 4, 14 over 2 is 7 times 4 is 28. A bus starts from rest at point A, accelerates for 2 meters per second squared for 10 seconds. It then runs at a constant speed for 30 seconds and then slows down at -4 meters per second until it stops at point B. Okay guys, this question is so long and I hate solving it, but let's just do it quickly. So a bus starts from rest at point A and it accelerates for 2 meters per second at 10 seconds. So first we need to find the displacement of the first part. Let me just draw it out so it's easy. You have A, and it accelerates until it reaches phase 1, and it moves at a constant speed until part 2, like stage 2, and then it decelerates until it reaches B. Okay, so yeah, let's solve it. So at A, it's at 0 meters. It's only to draw small stuff. And it's at 0 meters per second. Is the meters per second. Okay. Now, what's the velocity and the distance here? So for the velocity, we just use V equals AT plus V0. So V0, so A is gonna be 2, T is 10, and V0 is 0, so plus 0. So V is gonna equal 20. Equals 20. And for the distance, it's gonna be no way. Oh, okay, thank you. For the distance, it's just gonna be 1 over 2 at squared plus v0 t plus x0. Okay, so 20 meters per second. We found the velocity. Now find the distance. So 1 over 2 times 2a times t squared, so 10 squared, plus v0t plus v0t, so 0, plus, equals, that's gonna equal 2 times 1 over 2 is 1 times 10 squared, so it's gonna be 100. So 100 meters. Okay. Now we need to find the second part. So it then runs at a constant speed for 30 seconds. So this is easy. Constant speed, so URM. The formula is gonna be x equals vt plus x0. So okay, sorry. X equals 20 v for phase 2. The second phase mode equals 20 times 30, because 30 seconds, plus x0 is 100, because here we were talking about the second phase. So at the start of the second phase, it's 100 plus 100. So 20 times 30 is 600 plus 100, so equals 700. So here it's gonna be 700 meters, and the speed is gonna be 20 meters per second because it moved at a constant speed per second. Okay, now it decelerates. So UARM again, it's gonna be x equals 1 over 2 at squared plus v0t plus x0. Oh, but we don't have the time. We don't have how fast it slows up. So actually, my bad guys, you can't use this one. You're gonna use the time independent equation. I wrote that up for no reason, yes. Okay, time independent equation is v final squared minus v initial squared equals 2a delta x. So v final is 0 because it comes to a stop. V initial 0 squared is 0, so v initial is from here 20, so negative 20 squared equals 2. Acceleration is negative 4, 2 times negative 4 times delta x is x final minus x initial. We have x initial, just 700. We just don't have x final. This x final. It's gonna be x final for b. And it's gonna be basically because it's gonna be the x final for the whole thing. So that's what we're trying to find. So let me just do it on the calculator. Give me just a second. So 0 minus 20 squared equals 2 times negative 4 times bracket 700 minus x. Oh no, that's gonna give you 650. No, wait, my bad. I did x initial minus x5. It's supposed to be x minus 700. So you're gonna get 750. 750 meters. 750. The duration of phase 1 of the car's motion. So this phase 1, a car accelerates from rest at 3 meters per second until it reaches a speed of 18 meters per second. Okay, so V equals A T plus V0. V, so V is 18. So 18 equals 3 times T plus V0 is equal to starts from rest. So 18 divided by 3, so T is 6. 6. The distance traveled in phase 1. So now we have the time. Now we need to find the distance. So we're going to use the acceleration formula. So x equals, or delta x equals 1 over 2 times a, which is 3, times t squared, which we just got is 6 squared, plus v0t. V0 t, so t is 0. V is 0 because it starts from rest, so that's good. So just do it on the calculator. 1 over 2 times 3 times 6 squared. 54. The total duration of the car's motion. So here they ask for phase 1 only and phase 1 only. So now we need to find the duration for all 3 phases. Okay, now let's find phase 2. The car then moves a further 360 meters at a speed of 18 meters per second. So URM. So delta x, so delta x equals v t. So 360 equals 18 times x. So let me just do it on my calculator. 360 equals 18 times x. So x is 20. This is t. T equals 20. So phase 1, we got it at 6 seconds. Phase 2, it's 20 seconds. And phase 3, they just gave it to us, 9 seconds. So add them up. You're gonna get 6 plus 20 plus 9. It's gonna equal 35. 35. The total distance traveled by the car. Okay, so we already have the distance for phase 1. Let's put that up here. Phase 1. The distance is 54 meters. We solved it here. And phase 2, 360 equals 360 meters. Now we need to just find phase 3. How? We're going to use the acceleration independent equation because they didn't give us the acceleration. So the acceleration independent equation, it's delta x equals v final plus v initial plus v initial over 2 times the time. So v final is 0. Delta x equals 0 plus 18 over 2 times the time, which is 9 seconds. So 18 over 2 times 9, you get 81. So phase 3 is 81. Now you add them all up. So 54 plus 360 plus 81. 81, you get 495. 495. Acceleration of the dog during the first 5 seconds. Okay, so during the first 5 seconds, this is 5 seconds. And yeah, okay. From here to here, okay. So v final minus v initial over t final minus t initial. So -1 minus 2 over 5 minus 0. You get -3 over 5, which is negative 0.6. Okay guys, for this question, if they're both positive, so it's speeding up in the positive direction, A is going to be positive, so it's going to be greater than 0. But if they're both negative, it's also going to be positive. If they're opposite signs, it's going to be negative though. A is going to be less than 0. Okay? Alright, okay. So speeds up positive, so A is greater than 0 because speeding up is positive and in the positive direction. Slows down in the positive direction, no. Speeds up in the negative direction, also no. Slows down in the negative direction, so yeah, positive. Total displacement, so the area under the graph. So area of a triangle is 1 over 2 base times height. So it's gonna be 1 over 2 80 times 6. That's gonna equal, let me do it on my calculator, times 80 times 6. So 240 equals 240. A runner passes the start line at a speed of 1 meter per second and then accelerates at a rate of 0.5 meters per second squared for 10 seconds. Displacement for the runner during these 10 seconds. Okay, so the form is going to be 1 over 2 at squared plus v0t 0t delta x equals, okay, so 1 over 2 acceleration is 0.5 times 0.5 times t squared, so 10 squared plus v0t. v0 is 1, so 1 times 10. Put it on your calculator, give me 2 seconds. 1 over 2 times 0.5 times 10 squared plus 10, 35, equal 35. This is times 10, 1 times 10. The displacement of the object. So again, we need to just find the area under the graph. The triangle is going to be 1 over 2 base times height. So 1 over 2, 4 times 6. That's going to equal 1 over 2 times 4. So 2 times 6 is going to equal 12. And this one is 1 over 2 base times height. So, oh no, base 1 plus base 2 over 2 times height. So base 1 is 12 minus 4, so 8. Plus base 2, it's going to be 10 minus 8, so 2. Over 2 times height. So height is negative 6. So this one's going to be negative 30. 30. So 12 plus negative 30. It's negative 18. 12 plus negative 30 is negative 18. A block is initially moving at 20 meters per second and decelerates at a constant rate of 4 meters per second squared. What is the displacement of the block over the course of 6 seconds? We're going to use again 1 over 2 at squared plus v0t equals delta x. So yeah, 1 over 2 decelerates at a speed of 4 meters per second, so times negative 4 times t squared, so times 6 squared, plus v0t. V0 is 20, so plus 20 t times 6. Put it on your calculator. 1 over 2 times negative 4 times 6 squared plus 20 times 6. 48. It's going to equal 48. The distance covered by the airplane is... Okay, let's just read the question first. Boeing 747 is an airplane that accelerates from rest to 80 meters per second at a rate of 2.5 meters per second squared. Drag and drop the correct option. Okay. The distance covered by the plane. So here we're going to use the time independent equation because we don't have the time. So it's going to be v final squared, so 80 meters per second squared minus v initial squared, so minus 0 squared, equals 2a, so 2 times 2.5 times, it's a bit messy, I think, 2 times 2.5 times delta x. So do it on your calculator. Just give me 2 seconds. 80 squared equals 2 times 2.5 times delta x. You get 1280. 1280. The time needed for the plane to reach the 30 meters per second speed. The time need. Oh. Okay. So this one we're gonna use normal formula. So equals AT plus V0. We know the final velocity they want, so they want 30 equals A, which is 2.5, times T, which we don't know, so we put X. Well, let's just leave with the variable as T, so times T plus V0, which is 0. Okay, so you solve it on your calculator. So 30 equals 2.5 times T plus 0. We solve it, you get 12. But here there's no answer for 12, and I think here the quiz is wrong. Because the correct answer should be 12. Okay, the correct answer should be 12. But in the quiz, the answer is 32. Now, the way you would get 32 is if you put 80 as the V final. If you put 80 here instead of 30, 80 equals this, you would get 32. But they want how long it would take the airplane to reach 30 seconds, not how long it would take it to, how long it would take the airplane to reach 30 meters per second, not how long it would take the airplane to reach 80 meters per second. So here, the answer in the quiz is 32, but that's wrong. The correct answer is 12. Okay, it's wrong. Okay. The speed of a bus traveling due south uniformly reduced from 54.0 km per hour to 36 km per hour in a distance of 62.5. Give all the answers to 3 significant figures. The acceleration of the bus is... Okay, we need to find the acceleration. So first, this is in meters per second, in second and meter. So we need to change this from kilometers per hour to meters per second. So we need to divide everything by 3.6. Kilometers per hour divided by 3.6 gives you meters per second. Okay, you guys need to memorize this. So 54 kilometers per hour. 54 divided by 3.6 is going to give you 15. So this is going to be 15. I'm not going to add the meters per second because there's no space. And this is just going to be 10. Okay. So the acceleration. So 15. Okay, let's do acceleration. Sure. So we're going to use the formula V equals A T plus V 0. So V is 15. Oh no, V final is 10. Because it goes from 15 to 10. Okay, so V final is 10. Equals A, which we don't know. T we also don't know. Plus V0. Wait guys, I don't think this is the formula we used for a long time. Do we have time? And this is 62.5. Wait guys, I think we need to use another one. Because they give us the time. In a distance of 62.5. Okay guys, we have to use the time independent equation because they didn't give us the time. I thought they gave us the time, but I guess they didn't, so my bad. So we find it squared, so 10 squared minus 15 squared equals 2a delta x delta x is 65. X 62.5. 2a times 62.5. Do it on the calculator. So 10 squared minus 15 squared equals 2x times 62.5. You get negative 1. A equals negative 1. But they wanted 3 significant figures, so negative 1.02. Negative 1.000. Okay, so remove all that. We just know that this is 15 meters per second and this is 10 meters per second. Okay. The bus keeps this decelerating at the same rate from 54 kilometers per hour. It will take how many seconds to stop? This is the one where you use the other formula. I made a mistake. Okay. So here you use V equals A T plus V0. Okay, so V is 0 because you want to reach 0. That it will stop at the end. Okay, this is how much it starts at, which is 15 meters per second or 54 kilometers per hour. A is negative 1 times T, which we don't know, plus 15. Okay, so put it on the calc. 0. Don't even need to put this one on the calc. Like, you're gonna take 15 to the other side. It's gonna be negative 15. Negative 1 times what? It's gonna equal 15. So it's gonna be T is 15. 15. The distance covered by the bus. The distance covered by the bus cover before coming to a stop. But I need to fix the code. This is covered by the bus to cover before coming to a stop. Okay, so now we're gonna use the. Let me just erase this so we have space. Now we're gonna use delta x equals 1 over 2 A T squared plus V0 T. Okay, so delta x equals 1 over 2 times negative 1 times 15 squared plus V0, so 15 times 15. Put it on your calculator. You're gonna get 1 over 2 times negative 1 times 15 squared plus 15 times 15. You get to 112.5. 12.5, but they want 3 significant figures, so it's gonna be 113 because you're gonna round it up. Also, it's gonna be 15.0 because it's also 3 significant figures. Okay, a car moves along a straight path from A to B in 2 hours. It moves through the first 75 kilometers of its journey at 60 kilometers per hour, the rest at 80 kilometers per hour. So this one, we're gonna keep it in kilometers per hour because all the answers are in kilometers per hour. Okay, so first, we need to find the time it took to cover the first distance. So we're gonna use x equals Vt, because there's no acceleration, equals Vt, or delta x equals Vt. Okay, so V times T. This, by the way, guys, this delta x equals Vt is the same as Vt plus x0. Because if you just move this to the other side, this is x final and this is x initial. It's going to be x final minus x initial. Okay, so x equals Vt plus x0. So moves the first 75 kilometers. So 75 equals 60 kilometers per hour. 60 times t plus 0. So 75 equals 60 times t. 75 equals 60 times t plus 0. You're gonna get 1.25. 25. So the first half of the journey, or the first part of the journey, they took 1.25 hours. 25 hours. The rest, the whole journey was 2 hours. So the other half is going to be 0.75. Because 2 minus 1.25. Okay? Hours. So how do you find the distance covered in the second half? You're going to do 0.75. Wait, let me write the formula. It's going to be the same formula. But this time, the missing is x. So x equals v, so 80 times 0.75 plus, here x0 is 75 because you moved 75. Let's say this is 0, so you moved 75, so now you have 75, so then you moved some more. So here the initial for the second part is 75, so plus 75 kilometers from here. Okay, put this on your calculator. 80 times 0.75 plus 75. You're gonna get 135 equals 135. 135. The instantaneous speed of the car 50 minutes after it has started its journey. So 50 minutes, you need to find how many hours that is. So do 50 over 60. 50 over 60. 50 over 60 is 0.83333, and it goes on. So 0.833 is in the first half, because anything more than 1.25 would be in the second half, and for the whole first part of the journey it's at 60 kilometers per hour. Okay. So now you need the magnitude of the average velocity. Average velocity is displacement over time. And what did you get the total distance? It's 135 over time, which is 2 hours. So 135 over 2. Distance over time, you get 67.5. Okay. Whoa. Okay, next question. What do they want? The displacement of the car over the 20 seconds. And it's a VT graph. So you're going to do the area under the graph. So base 1 plus base 2 over 2 times height, because it's a trapezoid, so base 1 plus base 2 over 2 times height. So base 1 is 19. I don't know why this last part didn't make it 20, but okay, 19 times, here it's where is it? It's like this line, so 8, and here it's at 14. So 14 minus 8, it's 6. So 19 times 6. What times? Plus. So 19 plus 6 over 2 times the height, which is 20. So 19 plus 6 divided by 2 times 20, you get 250. Is that? So 250. The average acceleration over the course of the 20 seconds. So V final minus V initial, V final minus V initial. Okay, V final is 0, V initial is 0. So 0 minus 0 over time, so like over T final, it's gonna be 0, okay? It's gonna be V final minus V initial over T final minus T initial, but V final and V initial are 0, so. The distance traveled by the car is equal to the displacement, because the car doesn't change direction. Okay? Because look, it's accelerating in the positive direction. When it's accelerating in the negative direction, cool. Let's say it's moving like this, yeah? Accelerating the positive faster, moves faster, 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 moves at a constant speed, doesn't matter the speed. As long as the velocity is positive, it's moving in a straight line. In a constant, like, straight line, constant speed. But when the velocity is negative, that means it's accelerating, it's moving in the negative side. So if it just moves in the positive side, then yeah, the displacement and the distance are gonna be equal. If it moves upside anything, then they're different. But if it's in a straight line, then yeah. Okay. A motorcycle is initially moving from the origin at 2 meters per second in the positive direction, accelerates at a rate of 0.4 meters per second squared for 60 seconds. The velocity of the motorcycle at t equals to 30. So here what you're gonna do is you're gonna do v equals a t plus v0. So v is gonna equal 0.4 times 30, because they want at t equals to 30, plus v0 is 2. Okay, initially moving at 2 meters per second. Do it on your calculator. 0.4 times 30 times 2, or plus 2, my bad. 0.4 times 30 plus 2, you get 14. 14. Okay, now the average velocity in the interval 0, 60. So the average velocity is displacement over time. Right, so how would you find the displacement? You're going to use x equals 1 over 2 at squared plus v0 t. Displacement equals this. So the displacement is gonna be delta x equals 1 over 2 times 0.4 times 60 squared plus 2 times 60. Okay, so put it on the calc. 1 over 2 times 0, 1 over 2 times 0.4 times 60 squared plus 2 times 60. So you're gonna get 840. And the average velocity is displacement over time. So 840 over time, so over 60. Because 60 seconds. We finalize ratio of the finalized stage. Over times 60. 840 over 60 equals 14.